Good afternoon. It's great pleasure for me to be here. The first thing I'd like to do is acknowledge Food and Behaviour Research for sponsoring my visit across from New Zealand. I must admit that I've been here a couple of days, but I still haven't quite got my melatonin cycles right. So it's a little while since I slept, to put it mildly. Okay, I hope everyone at the back can hear me. If you can't at any stage, wave your hands and then I'll know. But you're right? Yeah, everyone seems to think we're okay. There's nothing worse than if you have to struggle to hear. Let's see what happens here. Okay, first of all, just my own statement of interest. I have authored a book on this topic from which I do receive royalties, and on occasions I do consult as an independent advisor to A2 Corporation and other agri-food companies in New Zealand and elsewhere, and also to government bodies on a range of agri-food issues. But I do not represent any agri-food companies. I retain independence in everything that I write, and I have no commercial interest in any product discussed in this address. I'm going to start with the end, perhaps some take-home messages. I do quite a lot of talks in Australia. You probably think New Zealand and Australia are the same country, some of you, but I can assure you they're not. But I talk quite a lot to some of the medical groups over there, and one of the things I've taken from that is that many of the health professionals, a little bit in New Zealand, but particularly in Australia, are now recommending milk free of A1 beta-casein as a frontline strategy for dealing with a range of problems. And by a frontline strategy, I mean that it's in their kit bag of tools, which is right up there at the front. That doesn't mean to say it's going to work 100% of the time. But in all these intolerance and related conditions, they're so difficult, they're so complex, you do need a kit bag of tools, you do need alternatives, and I'm saying to you that a lot of the healthcare professionals there have this one right up at the top. And these are some of the issues for a whole range of milk intolerances: bloating, nausea, constipation, diarrhoea, mild asthma, some skin allergies such as eczema, glue ear, some sinus issues, behavioural issues. It's a whole set there of issues which a lot of healthcare professionals are finding that using a product free of A1 beta-casein is pretty helpful. And of course in Australia you can get milk free of A1 beta-casein in every supermarket. That includes the product that is labelled as A2 milk from cows, but also, of course, goat milk products and sheep milk products. They also will be free of A1 beta-casein. As well, this is still part of the take-home message, I guess, to you to think about. Some Australian health practitioners do recommend milk free of A1 beta-casein for children who have a familial risk for type 1 diabetes. And milk free of A1 beta-casein may be beneficial for a range of childhood illnesses and for infant development. It's also apparent, I'm going to talk about these things, so these are the final messages, and you need to look to see whether I'm giving you the justification for these statements. It's apparent that the problem peptide from A1 beta-casein can also pass from a mother's digestive system into her own milk. Now, I need to make the proviso that people with IgE-mediated milk allergic conditions should not consume any milk, regardless of beta-casein type, except under strict medical supervision. So we know that there are a small number of people who can go into anaphylactic shock from any milk, and it's not always just because of the A1 beta-casein. But I'm saying to you the overall body of evidence in relation to A1 beta-casein is now very compelling. So, milk free of A1 beta-casein. It includes goat milk, sheep milk, buffalo milk, much of Asia, camel milk if you're in the Middle East, all milk from pure African and Asian cattle, and A2 milk. It's a branded product. And of course, human milk is also free of A1 beta-casein. So the A1 beta-casein, it's a consequence of a mutation that only affects some cattle of European origin. But of course, in the United States, Canada, New Zealand, Australia, all our cattle there are also of European origin. So it's widespread in all of those animals. The mutation, we don't know exactly when it occurred, but it's probably somewhere around about 8,000 years ago. And for reasons that are not fully understood, although we can hypothesise a number of possibilities, it's become widely spread within modern herds. So if you're wanting to breed free of milk, to get milk free of A1 beta-casein, the key point is that cows carry 2 copies of the single gene that differentiates A1 and A2 beta-casein. It's on the 6th chromosome. So there is what we call an A1 and an A2 allele, or variants, and they're co-dominant. What that means is that you actually have to have double copy of the A2 alleles to get milk that's free of A1 beta-casein. And if you have a cow that has one of each of the alleles, then she will produce milk which is part A1 beta-casein and part A2. To breed a typical, European type herd to A2, by that I mean having the double copies, it can be achieved in 1 to 2 cow generations. Under exceptional conditions, you can do that in 4 years, and I'm working loosely with some people in America who will be able to achieve it in that sort of a time frame. In New Zealand, for us, it's a 10 or 12-year journey through 2 cow generations. That's because of our different system of farming, and I won't go into the details of that here, but the Americans can do 1 or 2 things with their 12-month year calving, which of course people have here, and also using sex-selected semen a lot faster. So it does depend on what country we're talking about, and you just got to look at the farmer, what the options are as to how long to convert a herd across to get it totally pure. Of course, the big farmers, they just test all their cows, and then you have separate herds. Here's your A2 herd, and here's your A1 herd over there. So big farmers can actually be producing pure A2 milk early on through that process. A lot of talk about the different types of breed, and Paul is right when he suggested that the brown breeds tend to be a little bit higher in the A2 allele than the black and whites, but that message has got a bit twisted at times. The key message is that the specific breed is only a minor issue, and there's no difficulty in getting pure A2 herds from the black and white breeds. So what's the difference between the A1 and the A2 beta-casein? It's 1 amino acid and 209, so your beta-casein protein, 209 amino acids, and at position 67, it's a histidine rather than a proline. The original one was a proline. Now this causes substantial release on digestion of the peptide beta-casomorphin 7. Caso for casein, morphin for morphine. So it's a peptide or fragment that has opioid characteristics. What I'm going to try and do in this talk is differentiate between what's controversial and what's not controversial. What I'm giving you now is, at the moment, is not controversial. There's no doubt about it. It is released from all dairy products that contain A1 beta-casein. So it doesn't matter whether it's cheese or ice cream or yogurt or fresh milk. If there's protein there that is of the A1 type, then you're going to get the release of BCM7. We didn't know that 6 years ago when I first wrote the book, but we know that now quite clearly. This BCM7, it's a proline-rich opioid which binds to mu opioid receptors. For those of you who aren't biochemists, and I'm not a biochemist either actually, but I would say by training I'm an agricultural scientist, what the proline does is it sort of configures in a very tight way and is quite hard to break down. There's very few, there's really only the one enzyme that we know of that will break down the BCM7. So peptides that are proline rich, like gluten, like BCM7, have some special characteristics. BCM7 stimulates production of mucins, or the mucins, which were the proteins that make mucus sticky. No controversy about anything I've said so far. However, there is controversy about the implications of all of this. So, the evidence for health effects. Well, the original evidence was epidemiological and related to populations. We'll look at some of this. There's a body of trial evidence relating to animals. We'll look at some of this. There is cohort, case control and case study evidence in humans. And we'll also look at some of that. And there's in vitro work with humans, which we'll look at briefly. Now, there's also a lot of evidence related to autism and epigenetic factors in humans and animals. I'm not going to go there today because you've got other experts here that know more than I do. So that's great. I can focus on some of the other aspects. There are two very important new trials with mice and rats as to the digestive system effects of A1 versus A2 beta-casein. I'm a co-author of one of those papers, which was actually just published yesterday. It's just come out. I believe the results of both papers are powerful, and we're going to look at those in some detail, because I think those two papers actually change the balance somewhat in terms of the overall body of evidence that we now have. There has been one relevant human clinical trial relating to digestion, and that's now working its way through the publication process. I'm also a co-author on that. Other trials are on the planning stage. I can't say much about the completed trial until it is accepted for publication. But what I will say now is that the results of the rodent trials, which I am going to talk about, have been very helpful in interpreting some statistically significant human results, which hopefully will be published shortly. But as those amongst you as scientists will know, the publication process sometimes does take a little while. Now, there's a lot more I won't be able to cover today, just obviously because of time. Overall, I have about 500 references that have relevance to the beta-casein issue. Huge amount of evidence and information out there. Perhaps we can debate about this question of proof and what is proof. But anybody who tries to tell you, as some people will, that there's no evidence, well, that's just nonsense. The original work that sort of got things started was epidemiological. It related to diabetes and A1 beta-casein. And this particular graph comes from the New Zealand Medical Journal in 2003. And what it shows, actually with an R-squared of about 0.84, so it's an incredibly high explanation, very close association between the intake of A1 beta-casein and the level of type 1 diabetes. Now, some people have misunderstood why cheese was excluded. Yes, there's a very slightly higher correlation when it is excluded, but there's a logic for excluding it, which is that cheese is not usually eaten in large quantities by children. So you actually get a better indication of the amount of dairy products that children are eating by excluding the cheese. But it wouldn't matter if we did it with cheese. The overall message is the same. Now, this is, what's called ecological data, and people always will say very quickly, well, that doesn't show causation. Correlation never proves causation. Of course it doesn't. But when you have relationships that are significant at p less than 0.0000001, you have to say, hey, there's something there. It's not random, it is real, but yes, we have to look for alternative explanations. Lawgerson and Elliott looked at 155, I think it was, different variables to see if they could get other explanations, and they failed. Didn't matter whether they looked at latitude or sunlight or all types of other food. There was nothing that would give them this explanation. Not proof, but it's something to think seriously about. Now, that's been around for a while now, but I mention it because this is really where it all started. There have been animal trials for type 1 diabetes. They're controversial. There's some conflicting results. If you want to get that story, you're going to have to read my book. It's too long to tell here, but it's a story very much about how the game is played. It's not only about what is said, it's about information that is withheld. I am on record in my book as referring to some events as scandalous, and that includes the action of a very big milk company. They did not sue me. They did not sue me. When my book was published, my publisher, I might have insurance through my university, but my publisher, very brave, wouldn't have been able to afford the insurance. So he just said to me, you've got to hold back one key point of evidence, and you've got to tell the people that if they sue us, then that evidence will be coming out. So that's how we had to do it. With the animal trials for type 1 diabetes, I can say that I'm eagerly awaiting results from some current trial work. I'm not in those trials and doing them, but I've seen some of the preliminary results, and as I say, I'm eagerly waiting future results. As is so often the way, no human clinical trials, specifically comparing A1 and A2 beta-casein as causal of diabetes. Very hard to do, of course, because the gestation period from when you take whatever it is, the milk or whatever that's eventually going to cause it, it's years and years down the track. And I sometimes just remind people that with smoking and cancer, of course smoking causes cancer. But can you give me the double-blind clinical trial that shows it? No, you can't, because it doesn't exist. So this is the same sort of message that Alex is talking about, I think. Yes, there is a pyramid, but some things we just have to accept. There are very good practical reasons why you can't do it. Unfortunately, that does sometimes give a weapon to those who want to push a particular line. The fact we can't do them. But here's some interesting evidence. In Finland, genetically predisposed people drinking more than half a litre of milk a day, 5 times as likely to become diabetic as those drinking less. Now, that's a cohort study. The significance around it is p less than 0.01. So, yeah, it's epidemiological, but quite impressive. There is a big trial going on called the Trigger Trial. This is going across in a whole lot of countries. And the preliminary data from that is that babies aged 6 to 8 months fed casein hydrolysate, which means the individual amino acids, compared to standard infant formula, are less likely to develop positivity for islet cell antibodies, and at least one autoantibody. The expectation is that those people will develop the type 1 diabetes. But the main trial, we're not going to know till 2017. This is not A1 versus A2. This is a casein hydrolysate, right down to the individual amino acids, versus the ordinary infant formula. So this should tell us whether it is a peptide, but it won't actually. Unfortunately, they're not looking at the question of whether it is specifically the A1 beta-casein. There's a whole lot of immunology. I've got to keep moving here. We do know that there's peer-refereed science there. People with type 1 diabetes have enhanced level of antibodies to A1, actually that should be A1 beta-casein. It may simply be a manifestation of people with type 1 diabetes being particularly sensitive to antibody formation. That could be an explanation. But there is German evidence showing that people with type 1 diabetes have higher antibody levels to A1 than A2. And they've claimed very high significance around that. And there's, a patent out there which Fonterra owns part of, and they have this particular data as theirs, which showed that people with type 1 diabetes have the IgG 1+3 antibodies and that discriminates against A1 versus A2 beta-casein. But that's never been published. It's in the patent document, but for their own reasons, Fonterra wouldn't now want to proceed with that. Mechanisms, well, we know that type 1 diabetes is linked to gut permeability, the leaky gut that was talked about this morning, which of course is not diarrhoea, but I thought it was too the first time I heard it. That's not really controversial, that type 1 diabetes is linked to gut permeability. We know that BCM7 does enter the circulatory system for babies and some adults. All babies have permeable gut, they have to. We know that BCM is a strong opioid. We know it crosses the blood-brain barrier with ease, and that when you do that with animals, it causes bizarre behaviour. And it's been found in the brain of babies at post-mortem. And we also know BCM7 catalyses LDL oxidation. So what I'm coming to here, there's a whole lot of, there's a theoretical basis there, but as I'll point out in a minute, there's no final proof. But there's a logic there, deductive logic. It says it's not surprising that antibodies to BCM7 and A1 beta-casein are formed. And it's interesting that there is a homologous amino acid sequence in the GLUT2 glucose transporting molecule inside the insulin-producing cells. So there's the logic. It's what I call friendly fire. It's, classic autoimmune, where the body is trying to attack something. There's an immune defence, but misfires and friendly fire. It's consistent with what we know about genetics. It's the same story as this morning. Genetics is relevant, certainly increases susceptibility, but by itself, that doesn't cause type 1 diabetes. So there's no proof. Let's be clear. A1 beta-casein and diabetes, at this stage, there is no proof. There's just quite a lot of evidence. When we go to heart disease, and this was a paper in Medical Hypotheses, once again, very high explanation, 0.86 on this, R squared, not just R squared, 0.86. So very close relationship between levels of heart disease in the population and the amount of A1 beta-casein consumption. So just gives you something to think about pretty seriously. Animal trial, this is in the journal Atherosclerosis, been around quite a few years. Rabbits fed A1 developed arterial plaque on their aorta, whereas those fed A2 did not, and there's the significance. The only real criticism I've ever heard of that is, the animal groups were small. Yeah, they weren't very big groups, but that's what statistics is about. That takes all of that into account, and it still comes up with probabilities of less than 0.01. So this isn't chance. Some of you would know, some of the older folk like me as well, that when we were young, the big story for peptic ulcers was that you would have a high milk diet. One of those diets is called the SIBI diet. And then they found, hey, people with stomach ulcers that were getting put onto these high milk diets, they were dying very fast. At the time, it was thought this would have been due to the fat, but with the evidence we now have, that really doesn't stack up. This is highly suggestive of an A1 beta-casein effect, and with the stomach ulcers, you're having further permeability. Medical people I talk to, and they tell me that if a patient has to have stents put in, if they have ulcer conditions, and that's not dealt with simultaneously, then they say there's going to be a whole lot of inflammation and plaque around those stents within 18 months. It's not a scientific trial, but it's specialist doctors that are telling us that. A lady from the Czech Republic, Dr. Steinerova, has done some very interesting work. About 10 years ago, she identified high antibodies to oxidised LDL in some babies. Now that's pretty interesting because oxidised LDL is a very important marker of heart disease, and it's also strongly implicated in Alzheimer's. Subsequently, she found they were very high in babies fed formula, but not breastfed, and in males by a factor of about 50 to 1. By 2004, she was hypothesising that it was due to BCM7 and A1 beta-casein, but I didn't think she had hard evidence for this, and so in the 2007 version of my book, I really just pass it by. It wasn't convincing to me. Subsequently, she showed that these babies have very high antibodies to A1 beta-casein, BCM7, but not to A2. And then she did do a trial with piglets, and the piglets that were fed A1 developed high antibodies, whereas those fed A2 did not. In the 6 months of the trial, the pigs didn't actually get heart disease, so couldn't take it through to that end point, but she did find a causal relationship that the A1 beta-casein was leading to high antibodies to oxidised LDL. That work's not well published. Language issues come into that, and some of it is only published in the Czech language, some of it's in English. It was with babies, but the real implications are for adults. Now, in that area, there is further work forthcoming. It's not from Steiner over, but I know some of the work that is forthcoming there, and it's going to be exciting. It's going to be exciting. Infant development. This is one of the most important papers that we've seen by Natalia Kost, and it was in the journal Peptides. And her team, they come from Moscow, pioneered techniques for measuring BCM7 in blood, and that was a first. It's tricky finding this BCM7. They found that nearly all children fed formula have BCM7 in the blood, and approximately 30% of those children suffer a developmental delay. This development delay is actually around psychomotor development. So it's not about the physical development, it's about the connections between the brain and the muscles. And I haven't seen all her evidence, but she clearly has a whole lot of data there which links it to the serotoninergic system. Now, the interesting thing is that the children who suffer the development delay, it's not necessarily the level of BCM7 in the blood, it's whether that level can be, goes down between the feeds. So if you have a child who metabolises the BCM7 quickly, then there's no real problem. But if you have a child who's a slow metaboliser of BCM7, then you do have a problem. Yeah. Well, we've known that BCM7 is a risk factor for sudden infant death syndrome for more than 20 years. Let's be clear, sudden infant death syndrome, there's a whole number of factors there that are predisposing to it. And one way you can solve it is just how the baby lies. Don't put the baby on its stomach. Another way, probably or arguably, is by avoiding the A1 beta-casein. I have a very good friend who spent more than 30 years in Brazil as a priest, and he said, and in his part of Brazil, where he was, a big area, and he said everybody breastfed, and he said no child ever died in 30 years from SIDS. He said no child could die without me knowing about it because I had to bury them all. No child died of SIDS. That's anecdotal. But hey, sometimes it's all part of the rich fragment of, or patchwork of information. Casomorphins have been found in the brain stems of children who've died from SIDS, but obviously you can't do the comparisons with normal children. Evidence from Poland that babies suffering apnea-alti events, acute life-threatening events, they have 3 times the BCM7 levels of normal children, so that's case control. Now, the interesting thing is these same children have low DPP-4 levels. I think someone talked about DPP4 this morning. This is the one enzyme that we know of that breaks down BCM7. And this links back to Natalia Kost's work as well. The kids who can't metabolise the BCM7 quickly are probably kids who are deficient in DPP4. Bovine BCM7 being found in breastfed babies. What mum drinks, baby drinks. And there's another case of morphin BCM5, which is being found in the blood of breastfed babies. Has to have come from cow's milk. And there's some people, so the mums who haven't been drinking any cow's milk, they don't have it in their babies. Now, this is a really interesting study, which was published late last year in the European Journal of Nutrition. 3 key groups of mice. Some were just fed the chow. Other group was chow plus A1 beta casein, so it wasn't actually milk. They separated out the A1 beta casein and put it down their throats, and did the same with the A2 beta casein. With the A2, no effects. Nothing happened. No difference between A2 and that just fed the chow. But A1 beta casein raised levels 3-fold of the inflammatory marker myeloperoxidase. It also raised the levels of IgG, and IgA antibodies, and these are all statistically significant. And it also increased the toll-like receptors 2 and 4. Now, I've just taken some figures from those papers, and you can see pretty quickly that there's some pretty big effects, the difference between A1 and A2. So that's myeloperoxidase, that's interleukin 4, that's the IgG, that's the IgE, toll-like receptors 4, toll-like receptors 2. What does this all mean? Well, I don't think we know yet, but what it's telling us very, very clearly is that there are major immune responses in the digestive system to the A1 beta casein, which do not exist with A2. Very well done paper. Here's another one, AGRAT's trial in the International Journal of Food Sciences and Nutrition. It says there at press. Well, that's because I did this yesterday. Today it's out. So, yep, it's out there in the literature. It's a direct comparison of milk-based diets in which the beta-casein was at the naturally occurring levels within pure A1 and A2 herds. So slightly different protocol than the one with, I call it, the mice one. And there was about 40% of the diet was milk. And then the beta-casein would be a much smaller proportion of that. So it was milk that was being given. Collaborative trial involving AgResearch, which is a New Zealand government institute, and A2 Corporation, jointly funded by A2 and the New Zealand government, dollar for dollar. Work itself, totally undertaken by AgResearch. I'm a co-author of this paper. I was called in to assist with the stats, which are a bit unusual, and then on the interpretation and to assist in writing it. And another key author here, who's actually the corresponding author, Andrew Clark, is in this audience. So this is joint between A2 Corp and the New Zealand government. The results, well, this is really, I think, pretty interesting. The A1 beta casein slows the digestive system transit relative to A2. We know it's an opioid effect. How do we know that? Because if we give the rats naloxone, then the effect goes away. Naloxone is an opioid antagonist. It looks like it slows down the passage by about 3 hours in an 18 to 24-hour normal transit. And we've got statistically significant results at 8 hours, 11 hours, and then at 14 hours. It's starting to wear off at 14 hours. We expected to get it, strongly hypothesised, yep, we've got it. We also found that A1 has pro-inflammatory effects on the colon relative to A2. Here's this myeloperoxidase again. Levels increased 65%. That's an opioid effect as well. And we found that the A1 beta casein upregulates this enzyme, DPP4, by 40% relative to A2. That's non-opioid. apparently. That's interesting, but there's a good logic to that too. It's very interesting. Now, why is that so exciting? The exciting thing that no one's ever said anything really linking the A1 beta casein issue to type 2 diabetes, which is one older people get. Yeah, I'm going to have to watch for time. I'm almost through. I thought he'd have had a chip in me before now, but he hasn't. One of the reasons why this is so interesting is that there's a whole class of modern drugs called the gliptins, which are also known as DPP-4 inhibitors. And this is a modern class of drugs which is used for controlling type 2 diabetes. So here we have, on the one hand, you control your type 2 diabetes through a pathway which is pretty well understood by reducing your DPP-4 levels. And yet, hey, we're finding that A1 beta casein upregulates them. So it's about time, isn't it, that we got on and did some human trials for this one. Whereas we had these opioid effects with A1, didn't find anything with A2. Now, this just shows us the, there might be another little bit there. It's the MPO, and we can see here that these levels are much higher on A1, and it gets pulled down as soon as you give naloxone. Same to the A2 without naloxone, just with saline, and here with naloxone. So very clear, statistically significant result there. I've got better graphs of this now that it's actually been published, but when you get it in your pack, you'll get the proper quality graphs. And this is the same thing with the DPP-4, and statistically significant differences here, which are 0.01. So here compared to here, and here compared to here. This looks a bit high here. It's actually caused by one outlier, which has caused the standard error to be big as well, but there's no statistical significance in that one. Okay, so who's susceptible to all these things? Well, things like transit time, the mucin effects, which is the sticky mucus, it's possible for all people, you would think. The logic would say we're all susceptible to that. Similarly for DPP-4 and the pro-inflammatory effects and the immunological effects. Now, other conditions we would expect to see enhanced susceptibility for people who do have leaky gut. If a previous talk I gave, I just said, look, it's crucial, the leaky gut is crucial. I heard some talk this morning that people aren't quite so sure about that, and I agree as well. Leaky gut is going to be an important part of the story, but it may not be quite as important as what we thought a year or two ago. All babies have permeable digestive systems. Tight junctions only occur after some months. So they're clearly susceptible. And then there's all the people who, for a range of conditions, have gut permeability. And you're seeing the same old words coming up there: stomach ulcers, ulcerative colitis, Crohn's, celiac disease, viruses, antibiotics, and HLA haplotypes. Policy reviews, there have been a couple. Swinburne and EFSA. Swinburne supposedly said milk was safe, but when you actually see what he really said, here we are. I won't read it out, but he's saying, look, I'm not sure about this diabetes, but there's enough there that I would be avoiding A1 beta casein in these situations. And then he has subsequently come out, he's Professor of Public Health, he was in Australia, now he's back in New Zealand. The time to change the dairy herd is right now. So Boyd Swinburne is often used as someone who said all milk is safe, and he was very upset by the way the Food Safety Authority used that information. He actually has different views. European Food Safety Authority, they found there was no proof of cause and effect. They recognised the BCM7 was released, so that was agreed. They did agree that you get the release of BCM7 from A1 beta casein, but it was lost in the noise of when the report came out. They questioned whether BCM7 remained in the blood for sufficient time to have an effect. They essentially ignored the epidemiology, case control, all this type of thing, and the animal data, everything they they took the view, if you haven't got the double blind, move on. They ignored or their report predated the recent work from Russia, Poland and the Czech Republic. And they didn't consider intolerance issues at all. I simply say, even despite all those issues, the evidence has moved on since 2009. Conclusions, last slide, I think. Well, I'm going to leave it to people to make their own conclusion as to whether the evidence is sufficiently compelling to seek out, at a personal level, milk that's free of A1 beta-casein. And you've got different options in different situations. I've always been very keen at an international level that we should be breeding all our dairy herds away from A1 beta-casein. It's not particularly hard to do. It's a little bit complicated because there are some short-term patent issues that do need to be worked through. But I would love to see all the herds of the world converted to A2. Single gene, that makes it easy. Further information, well, there's my book, Devil in the Milk. That tells the story of what we knew up until the end of 2010. I'm very pleased to see that Food and Behaviour have been selling that book. I have my own website, and you can see the address there, keithwoodford.wordpress.com, and that's where I write on things that are new. So, for example, what I call the AgRats paper that just came out yesterday, it'll be a day or two, and then I'll get something up there in detail about it, much more than what I've given you here. And references to all of the papers referred to are available on that website. Okay, so there we are. That's the end of mine. Thank you very much.
I didn't say yes. No, you've really done very well. We'll have somebody before you.
Is there much interest in the UK farming community to convert the herds to A2?
I think most farmers in the UK probably don't know very much about it. Remember, I do come from New Zealand. I can say that there's a lot of interest in parts of the United States, and I know that I've influenced some thousands of farmers there to convert their herds. Mostly organic farmers, all the Amish community. It's funny how different groups pick up on it. There's an article coming out in the Swedish Farmers magazine in the next week or two talking about it. That goes to every Swedish farmer, but I can't give you I'm not the expert to talk about specifically what's happening in the UK.
A short question.
Yes. Sussex shorthorn cows, do we know if they are A2 or A1?
There's only one way to test for any herd, and that's to do a DNA test. You can't tell by knowing the breed or just looking at the animals. The only breed that is particularly high in A2 is the Guernseys. So we could, we would expect probably 90% of Guernsey cattle to be A2. With the Shorthorn, you'd have to test. And it's the same thing even for the Holsteins. You can go to one herd and it might be 20% of the cows are A2. And you'll go to another herd and it'll be 45%. It depends hugely on the specific bulls that have been used in that herd. So I can't give you an answer, but there actually isn't an answer except to go and test.
Perhaps I can ask a question. If the opioid is the main player, what is the evidence that you can turn off autoimmune disease by giving low-dose naltrexone?
I don't think we have that evidence, but I don't think most people would want naltrexone in their milk. But I think trying to use deductive logic
as treatment of
Sorry?
individual patients.
As treatment of individual patients, yeah. Well, all I can say is I think it'd be much simpler to go the natural way and get back to the original cows. But it's interesting to me that the DPP4 effect is not in itself an opioid effect, and so I would be I don't think we can say with confidence that we can't say with confidence that everything is an opioid effect. There may be other things operating there as well, and probably are.
Okay.
Yeah.
Any other questions?
Yes, please. Can you hear? Can you hear?
I can hear, I can't see, but I can hear.
Is there any difference between heated milk and cold milk? Organic and non-organic? Two separate questions.
Yeah. In my book, I left those questions open, and we thought that there might be quite a chance that pasteurisation would have an effect, particularly UHT, ultra heat treated. No evidence has come through to show that in the last few years, and I now think it's less likely, but like so many things, we've still got answers to come. So I suppose we've got to say that we don't know for sure. But if there is an effect, it'll be that the heat treatment increases the release of BCM7 rather than decreases. And that has, I've sometimes wondered about ice cream. I got off ice cream quite a long time ago because of concerns. And this is, I suppose, my own little theory a little bit. I can't prove this one, but I'm amazed at the number of people I know who, when they've had an unexpected heart attack, the type of people you wouldn't expect to have a heart attack, and they go and talk to their spouses, and they say, I say, did he used to eat a lot of ice cream? And often if not, they say, oh, he was addicted to it. Now, this is just anecdote, but sometimes from anecdote leads to hypothesis, which is well worth testing.
Could I ask? Wait for the microphone, please.
Can I ask if the homogenisation of milk is significant or not? Because it's very difficult to get milk that is not homogenised.
We have no evidence on that point. It may well be important, but we don't have the evidence, and therefore I haven't gone down that track.
Any other questions?
Can I ask a question?
There's one down here first, please.
Oh,
How long would you say it would take from going off the A1, A2 if you were having a problem with it before you would see the results?
Yeah, so the question was how long before you would get an effect. I can't say for sure, but I think we have quite a bit of evidence that for some people it's some weeks before you'll get the full effects, because you've got opioid withdrawal effects on occasions. I can only, isn't a terribly good answer either, but I mean, I myself happen to be gluten intolerant, and it was just like that. But I think with the A1 beta casein, that I think that can take a few weeks. But I heard a comment this morning, I think it was from Paul, that suggested 3 weeks. Give it 3 weeks and you should be able to see an effect.
Somebody at the back.
is there a difference in sort of mood-related behaviours between A1 fed and A2 fed sort of animal models or any sort of human work that has been done?
In animals, we don't have the evidence. One of the theories is that farmers sort of selected for A1 because the cows were more placid because of an opioid effect. But that's just one little theory. With humans, the evidence is very, very strong. But once again, it's not clinical trials, but the behavioural effects, some people will tell you, are just so strong. You know, we have so many stories of individuals. There's one girl in Australia who thinks that she's a teenager and she thinks I'm very closely related to God, and it's because of my involvement with A1 and versus A2. And essentially she came, you know, her parents would say she came back and joined the human race once she got off the A1 beta casein. And we have other stories of people, autistic children, for example, who well, to use the, you know, they're out of control, they're shitting themselves, they're just crazy, and then you get them off the A1 beta casein and they're okay. But let's make a very clear proviso. What works for one person doesn't work for another. We know of no situations where there's a downside to the A2. That's the natural one, been there the million years or so. But with A1, for a lot of people, there are benefits of getting off it. We can't say there are for everyone.
The last question is mine. It's le droit de seigneur or something like that. Can you exclude the fact or the possibility that drinking A1 milk increases endorphin production and it has nothing to do with opioid peptides from external sources?
So you're saying that it's not a... Well, if it was that the endorphins were increased...
If you want to answer it later, please do.
Yeah. I think if we developed a logic that the A1 beta casein was upregulating endorphins, I don't think we'd be seeing the reduced transit time or the increased transit time that we do with the A1 beta casein.
Yes, you would.
Okay, I suppose, it's not a good idea to argue with the chair. So what I'll say is that, there's a lot of mechanisms still to be worked out.
Because, as you know, if you're a fan of Karl Popper, which I presume you
yes,
are...
I'm very much a Karl Popper fan.
In order to have your hypothesis supported, you must do experiments to disprove it, not to support it.
Yeah.
And this would be a way of doing that.
Yeah, and let's try and find the funds to do this and a whole lot
I'll send you
more
a check.
work.
We now have to thank him very much for a super talk.